So as I said previously, we can determine which versions of Python to use with the UV Python command. So if we go back here onto the Linux machine here, if we type UV Python, if we type UV Python, you can see it gives you a list of different elements there, and you can choose things and so on. You can find versions. There's things like pin, where you can pin a specific version. You can upgrade versions of Python if there's point versions changes and things like that. In particular, what we're going to do now is we'll type UV Python list. Now what this will do is it'll give you a list of all the Pythons available for the current platform you're on. So if you're on Linux, you'll get ARM version, the x84-64. If you're on Mac, you'll get the ARM versions. If you're on an M Mac and so forth. Windows will give you specific Windows versions of Python. And basically these are downloaded directly and installed directly into your home directory, and I'll demonstrate where they all live and things like that in a minute. So I'm going to say UV Python install 3.13. So we'll go for 3.13 and let it do it. So you can see here now it's downloading CPython 3.13.5 Linux. It will install this. It takes a little while first time, but obviously once it's done once, it doesn't need to do it again. I have a tendency only to ever have one version of Python installed, unless I'm doing very specific things across different, things like that. If we do a UV Python list again now, what you'll see is you can see the system Pythons are still there, and it's also now going to list the 3.13 as part of it there, so you can see that that's installed. And you'll notice it's .local share UV Python there is where it lives. So it's installed in your home directory, ready to use. So you have full control over this when you do it. If I now do a UV init, and what I'll do is test project 2 here. If I go into test project 2, again, if I do a UV run main.py, py. Now you can see here it's complaining a bit that it's not picking up the correct virtual environment. That's because I'm still in the virtual environment that I activated previously, and I forgot to deactivate it. So if I deactivate, that will turn off the old virtual environment. If I run it again, and now you can see it's doing that. Now we can't really tell at the moment what Python's there. If I type UV run Python, what that's going to do is run the current Python environment here, and you can see that I've got 3.13.5 because that's the version of Python that I've installed. So if I want to just run a REPL, as you can see there, UV run Python will run. We're in the REPL. We can just do the standard sort of Python tests and stuff like that we would do. Now if I go back to test project 1 this time, which is there. And again, if I do UV run main.py, it's running as it did before. If I do UV run Python, you'll notice that this now is using 3.9. And the reason it's doing that is that is the version that was effectively pinned in this folder. So we've got this thing called .python version. That will read the version of Python that the project was set for. So when we do a UV init, as we'll notice if we go back to test project 2, and if we have a look at Python version there, you can see it's 3.13. So that's how it's managed. It's similar to how PyEnv worked from that respect. So if you're used to using PyEnv, it's very similar. So that works well. We can choose Pythons. We can choose the obscure versions of Python and things like that, and so on. And you can see that that's all working. Now, the next thing that UV is very good at is managing dependencies. And it manages dependencies by putting them into the pyproject.toml. So at the moment, I'm in this folder. If I type z dot, what it's going to do is it's going to open Z up in project mode. And you can see here's all the folders that have been generated as part of our project. We've got main there that we had. And in particular, here's the pyproject.toml. And you can see at the moment, it's got use Python greater than or equal to 313. So it's going to choose that one there. And at the moment, dependencies is empty. If we wanted to add a dependency to this, what we do is we type uv add and then the name of the dependency we want to add. In this case, let's just do something simple like numpy. Now what you can see is, again, this is downloading the numpy package and installing it, and it's installing it in this local virtual environment. But the beauty is, what UV also does is it will cache that install. So next time we use it, it will reuse what is already installed. It will still put it in the virtual env, so the virtual env will still have its own local copy of it, but all of the downloading and all the other elements are cached. So first time, generally slow. Subsequent times are a lot quicker because of this. So I should now be able to, I'll just do it in the REPL. Actually, well, first, you can now see NumPy has been added as a dependency there. Notice the numbering and everything else. I never said what version I want. What it will try and do is resolve it to the versions that work for the current version of Python and other tools that you import. So most of the time, the dependency hell you get of, oh, that doesn't work with this version, doesn't work with this version, is removed because of UV just sort of beginning to manage all of that for us, which again can, gets really useful in the long run. So I'll just do another UV run Python. I can just import numpy like that, and numpy.dunder version, and you can see it's in there. Now if I change back to test project 1, now if I do UV run Python like that, and if I try and import numpy, it doesn't know about it because they're isolated. They're in different virtual environments. They're different isolated elements. So every time I type UV run, basically it's going to use the environment that's in this folder. And that's why we use UV run, because it will pick up on the local environment, it will activate it, it will use the correct tools. If we were to go into this VM here and go into the lib folder, and into site packages there, you'll see that it's got NumPy installed, and that's where everything is installed locally to the project. And this is the isolation and reproducibility elements of Python that I was talking about previously when we were setting these things up. So UV at its simplest is going to manage all of these dependencies for us. We can either ship a pyproject.toml with these things for us, or we can create an empty project and then keep adding these elements together. Now, one of the key things that UV allows us to do, if I were to go through here, and at the moment you can see I've got the core files, the main, the pyproject.toml, which talks about the dependencies, and this lock file, uv.lock, which manages it. This file should be put into version control, as should this if you're using version control. But also, if we look in here, obviously we've got the venv, which is where everything's installed. If I remove that venv, so now we don't have any of that stuff there, we can either type uv run main.py, and you'll see it's recreating that venv and running it for us. And if we look now, you can see that it's back there. And again, let's do that. Remove it again. The other thing we can do is we can type uv. He says, there we go. Bit of a lag with my. We can type uv sync like that, and uv sync does the same thing. As we'll see later, what I tend to do using DuraEnv is I automate UV sync and activating the environments as we change into a folder. When we change out of the folder, it deactivates it, so everything just sort of auto-magically works, which for the sort of naive user makes life a lot simpler, that you're just ready to go. And it's quite easy to automate these things with a couple of files that we can just add to any projects. They're hidden files, so no one knows they're there. So at its simplest level, that's all we need to do when we're doing these things. We just keep adding files, we keep adding them there, and so on. We can add sort of numbered versions, we can add things with different indexes and things like that. I will look at some more complex projects later, but for example, if we wanted to now add another package, we just UV add, and if we go in there and say we want to add NCCAPY to this. Now, NCCAPY is interesting because it already has NumPy as a dependency. So NumPy was already there, so now it's only added Pillow and Pygame to the project. And you can see it's also added those things in there. If I go in and add another project there now, and let's, for example, say we want to pigments like that. It's gone through and it's added that package there. And again, you can see now the order that things get added in there and stuff is all managed by UV. I think it's, well, we can test. I think it's alphabetical. We add black, like that, and you can see, yeah, it just adds it alphabetically. So it's really that simple. No more messing around with pip install, no more messing around with requirements.txt. If you do have projects that have a requirements.txt, all you need to do is look up how to convert on the UV pages. It gives you a migration to PyProject. And then once you've got a PyProject TOML created, just delete the requirements.txt and we won't use pip to install anything anymore. This also includes Jupyter Notebooks and things like that, which I'll explain later. So we've seen that sort of basic workflow. What we're going to move on to next is a tool called DirEnv, and the idea of using this is to help automate our workflows, to make our lives easier, but in particular to make it easier for students, so things should hopefully just work as we're doing things.